In this next section, we're going to talk about finding vertical asymptotes of rational functions. So I have listed here the 4 steps that we're going to take. So first, we're going to factor the numerator and denominator, noting any restrictions on the domain. We're going to cancel any common factors, and the roots of any factors that are remaining in the denominator are vertical asymptotes. The roots of any common factors, ones that you canceled, are holes in the graph. Or in other words, discontinuities that can be filled. So let's look at our previous example to see examples of each one of these things. So this was our previous example. F of x is equal to x plus 3 over x squared minus 9, which I'm going to write as x plus 3 times x minus 3. So notice that we can cancel this common factor, and that would leave us with f of x is equal to 1 over x minus 3. And notice this is undefined when x is equal to 3. So x is equal to 3 is a vertical asymptote. And let's look at the graph, and we saw it right here. X equals 3 is a vertical asymptote. Now, this common factor that we canceled earlier, here, x plus 3 was a common factor. So if we look at the root of that common factor, x is equal to negative 3, what do we see? We saw a hole. And that hole is what's called a fillable discontinuity. Fillable because if we came through with a pencil and colored it in, we would fill in that discontinuity. All right, so let's look at some examples of graphs that we haven't seen before. Find the vertical asymptotes and any removable discontinuities of f of x is equal to 2x squared plus 5 over x squared minus x minus 2. All right, so if we took a look at this function and look at our steps here, the first thing we're going to do is factor the numerator and denominator, noting any restrictions on the domain. We'll cancel any common factors, and then we'll look for any roots. Okay, so f of x is equal to, notice that the numerator cannot be factored. There's no common factors, and this quadratic does not factor. But the denominator we can factor as x minus 2 times x plus 1. So there are no common factors. So what that means is that there are no removable, that's another name for fillable, removable discontinuities. In the denominator, notice that we have 2 factors, so x cannot be equal to 2, and x cannot be equal to negative 1. Those numbers aren't in the domain, so that tells us that we have vertical asymptotes there. So we have vertical asymptotes at the line x is equal to 2, and at the line x is equal to negative 1. So if you took some technology and graphed this function, that's the behavior you would notice. Here's another one. Find the vertical asymptotes in any removable discontinuities of f of x is equal to x squared minus 1 over x squared minus 2x minus 3. So let's start by factoring the numerator and denominator. So the numerator is the difference of squares, and the denominator would factor as x minus 3 times x plus 1. So the first thing to notice is that we do have a common factor of x plus 1. So if we cancel that common factor, we have x minus 1 over x minus 3. So the common factor is x plus 1. And what that tells us is that we have a removable discontinuity. And remember, a removable discontinuity is a fancy way of saying a hole in the graph at x is equal to negative 1. Notice that this function is not defined when x is equal to 3. So that's our vertical asymptote. So we're going to have a vertical asymptote at the line x is equal to 3. And again, if you took some technology and graphed this, that's the behavior you would notice. When you graph with technology, the removable discontinuities don't show up on your graph. So that's why you have to do a little bit of analysis on your own and not just depend on what you see when you graph it with your graphing calculator. So here, why don't you try this one? Find any vertical asymptotes and removable discontinuities of f of x is equal to x squared minus 25 over x squared plus 5x minus 6. So let's just go over the solution to that together. F of x will factor on top as x plus 5, x minus 5. The denominator is going to factor as x minus 1 times x plus 6. Let's just check that. That would give us negative 1x plus 6x, that's 5x. Yep, that's how it factors. Okay, so the first thing to notice is there are no common factors, so there are no removable discontinuities. There's no hole in the graph. And when we look at the denominator, we see two factors. So there's two vertical asymptotes. So there are vertical asymptotes at x is equal to 1 and x is equal to negative 6.